So we're recording, again, sort of this Zoom conversation, and what I'm going to do is actually just share my screen, and the majority of the conversation will be actually doing this, so let me do this right now. A couple of things. Off to the side, and if there are any, let me see. Okay. If there are any questions, please let me know. I'll have the chat open, so in case if there are any questions. So for the most part, today we'll be kind of running through the same material that I went through yesterday during the live performance, if you will, of this presentation, this workshop. Just to kind of give you some ideas in terms of what I'm sort of expecting in terms of, and maybe what you should be expecting for the workshop is, one of the things is that we do have that D3 in terms of its development does require some sort of development of code. So this is not going to be sort of as straightforward as something like Excel, where you take information and then you kind of put it into a couple tables, and then you might click a few buttons and get some sort of result at the end. The program we'll actually be utilizing today, and I do apologize if this information did not get out to everybody, but we kind of threw this together, this Zoom conversation together sort of at the last minute. But what we will be actually utilizing is something called Jupyter, and it's actually under a program called Anaconda. Actually, let me throw a link in that real quick as well. Anaconda, server download, and this is sort of our application that we'll be using to sort of develop the code, and this is what's going to be utilized to run what I have in GitHub currently. One thing to note, if by chance, just in case you're wondering, yes, you can sort of download Anaconda. I'm just going to be walking directly through what I have on GitHub, so it should be sort of straightforward in that regard. So if there's, again, sort of any questions while I'm working through this, either use, we can kind of chat on using Zoom here, or you can use the chat feature as well, and I'll keep an eye on that through the conversation. If by chance I would recommend, if possible, if people could sort of mute their ends of the conversation until they might have questions. Again, that might just help with background noise or anything like that. And if there's no other questions at this point, I'm going to kind of continue on from here. So for the most part, what we'll be talking about is a development open source library called D3. D3 stands for data-driven document. It's a web browser-based way of sort of creating visualizations, both dynamic and static visualization. It allows us to kind of do very robust visualizations that takes, as it sort of sounds like, takes data and sort of make it into visualizations pretty directly. So this is actually the website, if you're ever interested, D3.js.org. D3 has been around for about, its original version was called Prefuse, and then it became Protoviz, and now it's called D3, and it's been around for about a decade at this point, and I've been sort of following along for about a decade as well. For the data visualization, I just kind of wanted to introduce myself and kind of do some special thanks as well to the Institute for CyberSciences for helping me market and sort of share the communications of this particular talk. When I was doing the live version of this, we were utilizing a lab here on campus called Alt House, and teaching and learning and technology. That group here at Penn State was nice enough to help me in terms of getting that put together as well. Just to give you an idea of who I am, I just recently finished my PhD about 2 years ago, where I specialized in data visualization and social media and data mining specifically. Here at Penn State, I actually support multiple departments. This includes the Huck Institute for Life Sciences, the Institute for CyberSciences, and the Evelyn College of Sciences. So my work can be varied from creating vaccine maps in various parts of Africa to dust patterns on Mars. And so we can kind of hit the spectrum in terms of a lot of these conversations. And I use the same sort of visualization packages for most of this, that D3 one. So definitely a robust way of sort of communicating these ideas. When it comes to data visualizations, for the most part, I kind of think about this into sort of 4 different forms. One is the data part of it, obviously. One is the actual coding part of it. So as I mentioned before, just in case you're joining us a little bit later, there is some code development that goes on with this process. So it's not as straightforward as something like an Excel. So we talk about that a little bit. Some UI, UX in terms of user interface, user experience, so how people can interact with this information, because these are interactive visualizations for the most part, or they're basically dynamic visualizations. So we need a way to sort of allow people to click on things, select things, filter things, request more information, and a lot of times that's where that UI, UX part comes into play. And finally, there's this art part of it. A lot of it has to do with sort of how if something is visually appealing, a lot of times people will engage in it more often and sort of want to work with it more often and sort of stay on that visualization longer. So art is a big part of this in terms of using colors and shapes and sort of ideas and how so we can connect all these dots, if you will. So one of the main things that I'll get in terms of why the whys of visualization is why do we use visualizations in general. For the most part, and I have the quote here, but to paraphrase it a bit, it's basically if we have the ability to, if we want to see as much detail as we can and see the most decimal places, why not just use a table? Because that's going to be the most exact way of providing this information. So why do we actually use visualizations? And that's what we're coming to play in terms of starting this conversation. One of the first sort of examples I go into in terms of how when visualizations or graphics can go bad, in terms of misrepresenting information, I usually talk about the Challenger explosion, specifically how this information was being reported. On the screen here, you have some, basically, this is how they were sort of recording information during their test phasing. And you can kind of see here, this is launch 1, launch 2, the 2 rockets, and you can kind of see all the different test patterns that they were going through. Listed on here is some ways of showing just basically some issues in terms of what was going on with that particular rocket, specifically the O-rings, which ultimately became sort of the issue. Also, it lists the temperature as well. So basically, this was the information that was being utilized by NASA officials, government officials, to make decisions based on if they should launch the rocket or not. If we take that same information and just plot it simply on an XY coordinate plot, you can see how this conversation changes very quickly. Basically, as we decrease decrease temperature being at the bottom here, and the amount of issues that are going on with specifically the O-ring. As temperature decreases, we exponentially see an increase of damage that occurred to specifically that O-ring, and that became sort of the faulty part of the actual rocket. And it was about 36 degrees on that given day, 38 degrees, give or take. And so basically that's what led to sort of the explosion. And again, this is not the direct relationship, but it sort of shows how some of these issues could have been resolved beforehand. Also, in terms of visualizations, I always think about this in terms of one of the bigger topics that is going on right now is the idea of artificial intelligence. The counterpart to this, or at least the counter conversation about this, is also this idea of intelligent amplification. Basically, how can humans work with computers and vice versa? And for the most part, visualizations is one of those better mediums to help put that conversation together between a human and a computer to sort of have them sort of bridge those gaps together. So it's another sort of positive way to showcase visualization information. I actually have a separate slide set. The reason why I'm not sharing these particular ones is because I took a couple pictures from a book and I didn't feel comfortable then posting this online. So for the most part, these are going to be sort of separate slides for a moment. Last thing I'll talk about in terms of why we visualize information is sort of the idea of general patterns we see in data. If we look at sort of January, so here's just some random information in terms of domestic versus international sales through the entire year. And for the most part, if you just sort of glean at this information, you're not going to see any general patterns per se. You might see a couple of differences here and there per month, but for the most part, you're not going to see anything too specific, if you will. Again, looking at this, looking for general patterns. For the most part, humans are, we're very good in terms of picking up visual patterns. So if we visualize this information, we can see a little bit differences. We see a sawtooth pattern. We see a dramatic dip in terms of the international sales via August. We see a number of different patterns that can sort of form from information. High lows, mediums between, things like that. Things that go, gradually get increase, decrease, how much it increases, decrease. decreases symmetry, things being skewed one way or the other, intersection of lines or information, clusters, groups, repeating patterns, anything like that. So there's a number of different ways we can actually pull some of that information glean from this information from visual means. And so again, this is another mean why we sort of go into the visual medium to sort of pull this information out that we might not necessarily see if we were looking directly at the data. There are three different types of visualizations, at least from my definition. There's not necessarily an agreed upon definition of a lot of these. For the most part, one is the infographic. These are something that is human-driven, author-driven specifically. So they have a specific message that they're trying to get across, and they'll use art as a way to sort of express as given ideas or what they're trying to sort of push in terms of what they're interested in talking about. Modeling basically is taking a real-life system and actually taking and sort of replicating that system online. And also visualizations being sort of this idea that we're taking data, but we're not quite modeling it, and we're trying our best not to be sort of author-driven, if you will. We're more user-driven. We want to give the information, and we want the information to be sort of expressed based on the visualization itself and the data itself. So the number one question in terms of when I do these types of talks, I have this type of data, what visualization should I use? I'm actually going to step out of here for a moment. And if you would go into the slide set that I provided in terms of the GitHub account, there's a document called Visual Vocabulary. This is kind of my go-to in terms of providing information. And if I have this type of information and I'm trying to express it one way or another, this is a good little chart that kind of gives you that idea of, I want to show correlation. This is how you might go about doing it, using scatter plots and things of that nature, or geographic information, magnitudes, parts and wholes, things of that nature. So just a nice little document to kind of say, this kind of gives you a good starting point in terms of this conversation. One thing I'd also like to mention is that even though I have some of those templates, if you will, there's a lot of different ways to express information visually, from things like tree maps, spark lines, stream graphs, or steam graphs. You can sort of showcase the information in sort of unique and sort of a lot of dynamic different ways. Here I have something called hive plots, star plots, and parallel coordinate plots. Might have heard of these, but for the most part, there are ways of taking multiple dimensions of information and plotting it on one way of sort of plotting that type of information. They kind of all do the same thing, but there's three different variations of this type of plots or graphs, if you will. The last thing I was just going to talk about was one of the premier sort of researchers in this field, Edward Tufte, basically talks about this idea. He wrote a number of different books in this regard in terms of visualizations and graphics, but the main focus when it comes to visualizations is taking multiple dimensions of information and then projecting it on a two-dimensional plot, if you will. So that's the last thing I wanted to mention specifically from the actual slides for now. I'm going to minimize this for a second. So to help start this conversation specifically with the coding and sort of involved with it. And again, when I was hoping for most people to have sort of installed or at least getting together or sort of downloading maybe during this first part here, was this program called Anaconda. Anaconda is an open source platform that allows you to do a number of different things. So right now, again, hopefully on my screen, you can see a number of different programs that are available. These are all open source, free, available for anyone to utilize. And so basically I'll be utilizing something called Jupyter, and that's Jupyter Notebook here. And when you click on launch, it should open up in your browser a screen that looks like this, which will have a number of different folders. And for me at least, again, I'll open this up over here. It is showcasing under my C drive. If you go under your username, under users, for me, it's going to be PMD19 for obviously for my account, for this computer. And then it basically is showcasing all the folders in here. And for me, I created a folder called Anaconda Projects. You can name it whatever you want. But for the most part, you're going to have a folder that you probably want to put all your Anaconda or Jupyter projects inside. And so once you put anything in here, if you refresh this screen, you should see it eventually on this page here. And for the most part, again, I'll assume that you have some sort of folder called Anaconda or projects or something to that effect. From there, so obviously I have a number of different projects listed here, and so that's all the different projects I work on routinely through the university here. But what we want to actually do is go into the GitHub account that I had sent to everybody. Move this over for a second. Under the data workshop, let me move this over. Under the data workshop, again, that link it's GitHub/DudasPM. Data workshop, and underneath there you're going to see a number of different folders. If you go specifically into the data workshop one, you should see a button that says clone or download. And when you click on that, you should be able to download the zip. And that should only take a few moments, and that will download all the files that we'll be talking about specifically for today. And so when I open this up and unzip it, check all. I should have a folder called Data Workshops-Master. That just means it's sort of the most recent update, if you will. And then I throw it into that Anaconda folder that I just mentioned. So if I go into here, under Users, under PMD19, and then Anaconda, I'm just going to drop this folder in. And if everything went as planned, there should be now one called Data Workshop-Master. And then inside there, you'll see Workshop 1. And then this is going to be all the files we'll be talking about today. So you're going to see a couple files here. A couple that we don't really need to worry about. One is that visual vocabulary that I just mentioned beforehand, the PDF. The other one is the one I'll be talking about specifically is called D3.tutorial. And then these notebooks are called IPYNB for IPython notebook. Question? They should not necessarily be tied to PCs or anything like that. They're natively run within Jupyter, but I don't think they're necessarily tied to any kind of either PC, Mac, or Linux or anything like that. If you are running into any issues while I'm going through the tutorial, please let me know. Maybe we can work offline to kind of correct these issues. But for the most part, again, there's another way to actually view what I'll be talking about today. If you go into that GitHub account and then click on the D3 tutorial, you'll see all the code that I'll be talking about throughout this conversation. One of the things you can also do is if you go to, and I'll put a link in the chat as well, a website called NB Viewer. Let me put that in now. If you go there and just copy the GitHub, DudasPM, Data Workshop, D3.tutorial, you just copy that exact link and throw it right in here. It will actually display it exactly how I'll be seeing it specifically on my screen here. So you won't be able to interact and do any of the changing of any of the code, but you'll see exactly what I'll be talking about and working through it, even the actual visualizations themselves. So you'll see the graphics as well. So that's another way to actually go about doing this. Again, if we run into any issues, please let me know. Maybe we can talk afterwards and make sure we can correct these issues. But for the most part, this will at least kind of get you going through the conversation. I wanted to showcase a project that I've worked on before. This was specifically this is a D3 project, and sorry, the chat's in the way, so move it up here. Basically, the reason basically this is a D3 project, and what we were trying to showcase specifically with the faculty member that I was working on was how the count of antibody counts can sort of reflect infection dates. I won't go into too much detail because this is not specifically my research, but this is one of the ways you can actually take D3 and make specifically an animation. And one of the cool things about D3 is the fact that, like I said, it's meant for data-driven information. All this information that you're seeing on the screen, the coloring, the movements, everything in terms of even these color palettes and things like that are all driven by the data itself, which is, makes it a lot easier for development. It makes it a lot easier for if this data ever changes, I don't necessarily have to go into code and put this information in again or anything like that, because it's basically using the information to sort of tell the story, if you will. And it was just a short little video, but for the most part, it's kind of an interesting way of taking data and just a comma-separated value type of data, put it into a visualization in terms of D3, and create sort of a dynamic animation at the end of this. So I just want to showcase one of the projects I'm currently working on and putting together. For the conversation today, our data set is going to be, one of the things, I should mention this as well, is within Jupyter, you're going to see basically cells. And each of these cells is basically a little fragment bit of code. And one of the nice things about Jupyter is the fact that you can sort of utilize it to sort of, at least for me in terms of thinking about a project, it lets me sort of separate ideas from one part to the next. And basically, if you go up to cell and then run all, this will run each of those cells. And it'll go from the very, very, very top cell and work its way down the page, as you might obviously read like an actual book or an article or anything like that. It's going to go from top to bottom. And so what you can do at the top is sort of have a little bit of code which will feed into the next cell, which will feed into the next cell, which will feed into the next cell. Nice little way of sort of actually putting together your thought process as you're kind of going through development processes. For this conversation that we'll be having today, a lot of these are going to be just sort of small changes from one step to the next step, if you will. And I'll kind of point those out specifically. If you want to as well, you can also just run just each cell. So let's say if you wanted just to run this particular cell, you can go into run and just run cell. And that'll just run that one particular cell. So if we update information here, it'll just rerun the code in this given cell. And this will make more sense as we kind of move forward. Specifically, we're going to be starting off, and for the most part, there's going to be points where I'm just going to sort of just copy and paste from one cell to the next. And the reason for that is I don't want to necessarily try to have you memorize and learn specifically the Jupyter environment. Jupyter is just our way of taking, having a way to sort of communicate some of these ideas and kind of move forward with it, with the conversation, if you will. Because D3 is a web browser-based visualization package, typically these conversations will have to start with, a web server, developing an HTML file, developing a JavaScript file, and maybe external things like Python or PHP. This helps sort of minimize the amount of sort of that conversation. So everything we can do here, a lot of times it's going to be, again, sort of copy and paste from one cell to the next. But for the most part, I might skip over a couple details here or there. I'd be happy to answer any kind of questions about this, but for the most part, I'm just going to kind of point out the main features of a lot of these. And that's where the conversation is going to be for the most part. This first cell here is basically saying we're going to create some JavaScript. And in this JavaScript is basically the web browser's programming language, if you will. And all we're saying is for this entire web page, we want to have one data set. So if window means basically this entire window for this particular browser. And so we have a data set that is literally going to be an array of 6 different things. And that's 6 different numbers, 2, 3, 6, 19, 23, and 35. I understand that this is not the most exciting data set we'll ever run into when it comes to development, but it kind of helps in terms of just kind of keeping things small for now. And my main hope is basically by the end of this that I can kind of just teach you the small nuances of D3, and then we can sort of talk about a larger project, if you will. I do include one of those as well. If you go under complete.buzz, I'm going to walk through this a little bit later, but this would be sort of a complete project with an actual data set. But again, we'll just kind of stay within D3 tutorial for now. Again, so our data set throughout the rest of this conversation is going to be an array of 6 different things, 2, 3, 6, 19, 23, and 35. I'll kind of talk about that more moving forward. But for now, I kind of just wanted to walk through a couple simple examples of just how HTML in general sort of is formed and put together. And that will help a lot when it comes to when we talk about D3 in particular. So in this bracket here, I have HTML code, as it sort of specifies here. And so for the most part, we're going to be sort of focused on here for the moment. What we have here is basically an HTML document. An HTML document, all it has is starting block and a closing block, saying that this is an HTML document. And there's 2 parts to it. There's a head, basically a header, if you will, where you can kind of put some meta information in, so the title. And then the body. This is basically where the body of the information will come into play in terms of what you see on an actual web page. If we run this particular cell, it's just going to say text, because the only part that is actually in the body that is text is that word text, if you will. And so if I change this, so I say, hello, everyone, and then rerun it, you're going to see the words hello, everyone. It's basically emulating an actual browser so that you can kind of see this is actually how you would go about creating an HTML page. One of the things that kind of came about with HTML is that it was never meant to be sort of well formatted, if you will. So here's a HTML document where I make some mistakes, if you will. So I have head, and then I change it to the word header. So the opening and closing are different. The word body is missing the B here. I have capital letters over here, and I added a D over here. The interesting thing about this is if you would put this on a web server, it would actually run properly, because it's not specific to one of the special, there's not a lot of standardization when it came to the HTML file. And that's where it brings into the next conversation of something called XML. They show that. XML is something that's it's basically well formatted. It has opening and closing that are the same word, all lowercase. So we have a note here, so it goes from inside the note, we have send it to somebody, from somebody, has a heading, and a message in between as well. Let's see. Just because it's making that text red. This is only important specifically because of the fact that I'm going to show you sort of a more advanced version of that, if you will. Specifically because this is how, when we're going to be talking about D3, it's going to be creating something called an SVG object. And how it's sort of formatting and putting this SVG object onto a web page is sort of the same way that you're going to be seeing this note that I have. So we have a note that sort of says, within the note, there's an address, and the address has a to and a from, a heading, and then the message itself. So if we're going to be talking about this, we're going to have an SVG sort of view box, or basically it's sort of the place where the SVG object is going to go into play. And then we're going to have basically sort of circles, we're going to have lines, we're going to have polygons and things of that nature. And I have an example of this coming up very shortly. But we're going to be thinking about this as sort of, we're walking through sort of this idea of this process of, we're going to have sort of declaring an open brackets, and we're going to be thinking about it and subdividing this into sort of smaller subsets, if you will. And let me show you the example that I have going here. On the next line, I have a polygon. So this is the HTML file. The header for the most part is going to be sort of the same, but instead we have this SVG object. And all this is doing is telling the browser that there's an SVG sort of viewpoint, or there's going to be an SVG object here. Viewpoint's the specific name that it sort of utilizes. And then anything inside of this is going to be sort of whatever that object we're looking to sort of put into play. In this case, it's going to be a polygon. Now, a polygon needs a couple sort of meta information. You need to know the points, obviously. So there's 3 points, and it's going to sort of draw them for us. And then it's going to have a style. And style basically tells you, what kind of fill do we want to have? We're going to have lime green. We have stroke, which basically is the stroke we're on the outside of it. We're going to make that purple, and we're going to have a stroke width as well. And so this is basically, if you're interested in making an SVG object, here you go. And for SVG, it's going to be something where it's as simple as you can create a polygon, you can create a circle, you can create a line, you can create a rectangle. They're very sort of simple in terms of their paradigms, and that's how a lot of these things are created. And if you remember, if we go back to that video that I was just showing a few moments ago, all it was a bunch of circles moving from one place to another with a couple lines sort of illustrating that there was some sort of motion, and then a couple rectangles. So that's a lot about what all that's going on. An axis or anything like that is just a couple lines here and there, and then some text as well. And text is another thing that you can add with an SVG as well. So this is sort of how we used to do this. We used to create these SVG objects sort of, we'd have to sort of program these out or use some other sort of language to create these. And then basically D3 sort of came about. D3 has been around for about 6 or 7 years at this point in time. It's currently heading into version 5. We'll be using version 4, which is the most up-to-date one that's sort of made available. And so, again, which is not in sort of a beta form or anything like that. And this is going to be sort of our template for the rest of this conversation that we're going to be having today. I'm not going to again go into the minute details of what's going on, but I'll mention that all this is saying is that we're going to be running JavaScript within this given cell, and also we're going to be applying something called a div. A div is basically sort of a placeholder, and what it's doing is placing the div basically right here in this bottom portion here. Let's see if I can do this real quick. What I'm going to do is, hopefully if I can do this really quickly, is add a stroke around our div. And okay. This is not working as quickly as I'd like it to. I'll kind of just keep moving from here. Anyways, the div is basically sort of a placeholder for where we want to have this information. That's right. Never mind. I'll just keep moving. For the most part, again, I just wanted to showcase that there's a div or a divider. This is basically sort of a placeholder for us to put the visualization at. And so you will just keep adding these specifically to each of these cells. And you're going to see this repeated throughout the rest of the conversation. There's a function called require that's pulling the library for us, so that basically we don't know how to do anything other than add this particular line to actually get the D3 code running properly. And then once you do the require, you're going to feed in that D3 object, and then the rest is going to fall into place from there. So the actual D3 code is right here. So specifically, it's going to have sort of what you're going to do is sort of select the div that I just sort of mentioned before, and we're going to add and append and sort of do some of that particular this polygon that we're just kind of reproducing from the example above. And so what we're doing here is basically reproducing exactly what you see up here. We're creating a polygon. So the first thing we do is create the actual SVG sort of viewpoint. So that's what this is here. And so that gives us, we're on the placeholder of the div, we're going to have an SVG sort of viewpoint, a place to put the SVG object, and then we append a polygon. And then that polygon is going to need some features to it. So things like an attribute will be points. So the specific points, again, sort of replicating exactly what we see up here, down to here. And then a fill in terms of the line, stroke purple, stroke width 1 pixel, basically, so it has a little bit to it. If I want to, I can go through here and change it to 10 pixels, and it'll really heighten that stroke around the actual object. Or if I want to change the fill, I can change this to blue. It'll change the blue for me. Again, all you need to do if you make small changes here, you just run cell, and that'll basically rerun this code and change it right there in front of you moving forward. So you can kind of, if you want to play around with this, you can kind of change a few things here and there. And so for the most part, a lot of people at this point will look at this and say, well, this looks like a lot less code. This SVG than just a polygon looks like a lot less code. Why would I want to do sort of this more verbose selecting and appending and things like that? This comes into play more often when it comes to actually creating sort of a more high-end, something that's driven actually specifically through the actual data itself. So our next example is going to be using that data set that I showcased before. Actually, I'm going to go up there and just make a copy of it so we can know exactly what I'm talking about. Okay. So my data coming into this point is, again, a simple little array that does, only has 6 points to it, but we want to actually make something out of this. In this case, we're going to make a couple of circles. If you're interested, I added a link here in terms of some of the information you're going to need to create, let's say, a circle. I use something called W3 Schools. I've been using this resource for years now. It's a wonderful resource. Kind of just gives you some basic tutorials on a lot of different things, one being SVG graphics. So let me jump over here and I'll just show you what I'm talking about. So to create a circle, all we need to have is a X position and a Y position and a radius. And for the most part, that will allow us to create the SVG object, if you will, that specific circle. So one thing I want to make mention before I kind of go down this particular path is what I'm specifically talking about when I say something like SVG. Let me get my presentation back down. Okay. So when I talk about SVG, typically most people, when they think about graphics or any kind of image or anything like that online, or something you're creating, or a graphic or something like that, they're typically thinking about things called a canvas object, or something that's sort of a raster, if you want to talk about it that way, but basically something made of pixels. And so I have an example here. I'm going to stop real quick. So this would be an image, a PNG file, a JPEG file, something like that. Now with something like this, basically all that's going on is for each of these pixels, so each of these little points, a color is represented. So black for the most part, a little bit of white here, zoom in a little bit, white on the stomach, a little yellow and orange here. Basically each of those pixels represents a color. And the issue is that once we if we want to, let's say, zoom into this object, we see that we have a lot of issues in terms of the quality of the image after a little while. Basically that's because you're stretching these images, these pixels out so far that you start to see sort of the inner work, the cracks in between the pretty picture, if you will. And so that's one of the main issues, because of the fact that there's no way to actually expand that space. All you're doing is basically kind of forcing the computer to give you more and more details when there's not as many details available to it. When I talk about vector graphics, or SVG, this is another example, but this time it's made actually specifically with vector graphics in mind. Vector graphics is basically something that uses an XY coordinate plot. If you think about this, if you have and I am going to be using Microsoft, some MS Paint here just to kind of think about this, but let's say we have an XY coordinate plot. We can think about if we add an object, let's say a circle. If we wanted to zoom in, all we need to do is redefine our XY coordinate plot, and that redefines the circle, so it kind of makes it a little bit larger at that point. And so objects are basically recreated. They're not pixels per se, they're actually SVG objects, or vector objects. And that's why you can create things like the simple things like circles or lines or polygons or things of that nature. So if we zoom in this image, really zoom into it, it's never going to lose its quality, because all we're doing is recreating that XY coordinate plot and basically making it larger, smaller. But for the most part, it's all we're doing is redrawing either in this case a sort of a polygon or a circle or a line or things of that nature, and just redefining it based on that new coordinate system. And so when you're actually developing a lot of these these D3 projects, these SVG objects and things of that nature, they're actually really good for things like publications or presentations, because no matter how small or how large, it'll always look at its sort of its highest quality, because it's basically sort of adhering to that specific coordinate plot. So a lot of times people will take these images that we talk about, use it for a paper, but they'll also use it for a poster presentation. And they don't have to worry about sort of that losing that quality, if you will, because again, this is what SVG objects are specifically made for. So for the most part, this is our first example of actually using data to control the actual creation of these objects. And again, we're going to be creating a circle. So what we talked about before was we need sort of a place to put this in terms of where it's going to be located at in that XY coordinate plot. So we need an X position, a Y position, and then again a radius, so how large the actual circle is going to be. And for the most part, if we would just take this, and so our data is going to be 2, 3, 16, 6, 19, 23, and 35. The way we actually go about doing this is we have to do something called a select. A select basically says, I want you to go find this particular div. That div is even though I sort of specify over here, the div is actually located down here. And I'll be giving these all unique names, so an ID. So when we create these divs, we're going to have something called an ID, and that ID basically gives it a name. And so I can sort of call this particular area or this particular graph, if you will. As you kind of progress, you're going to see that they go very creatively from graph 1, call it graph 2, down to graph 3. And again, that just helps me in terms of kind of making sure everything is showcasing right after the actual code is being specified. So the first thing you do is select that div and say, I want you to specifically give me that div that's named. And that's what that hash symbol means. Basically, it says find me a div with an ID that is graph1. And so that's what we have it specified up here. And when it does that, it's going to append an SVG object. And then that will give it some attributes in terms of width and height. One thing I'll make note of is that you're also going to see this little bit of code here. Typically, you wouldn't have this. This little bit of code is basically my way of each time I run this, it erases whatever is originally there and allows me to recreate it down here. But typically you're not going to have this. I just need it specifically so if I keep changing the data, so if I change this from 35 to 305, it makes that specific, circle with that information. But maybe I want to go back and make it. I want to change this back to 35. I need to erase what's there, and that's what this line here is specifically for. And again, I'm going to be copying and pasting a lot of this moving forward. So what we're doing is we've created our SVG, and I named it Viz. You can name this whatever you want. I can name it Apple. I can name it Banana. Doesn't really matter. All we use that for is specifically so we know that whenever we try to go through and actually go and actually add the data, it knows where to adhere it to. So if I run this, it should work properly as it does. So this line here is basically doing the same as sort of declaring this opening and closing block and saying, I want it to be a width of 400 and a height of 400. Now we actually have to give it some data. This part is usually sort of counterintuitive if people start learning this process of starting off. But what you actually need to do is, again, sort of select all circle. And all that is basically saying is, within this SVG object, I want you to select all the circles. Obviously, there's no circles at this point. We haven't really created anything. And yes, I know there's one down here, but for the most part, we haven't really, we're at this point in terms of the code, we haven't really created any circles at this point. All this is doing is it's selecting circles that are available, which is none, and which allows us to then say, okay, here is some more data. And that's where data comes into play. So let me change this real quick. I'm going to name this data points. This will show the case of the difference. So data points. I'm going to change that to data points over here. There you go. Sorry about that. So to declare that it's a variable. Basically, data points here is where we this is sort of the code that we use to actually put data into our actual D3 plot, if you will. So this is how we sort of feed that data in. From there, we enter in more objects. So we're going to append a new circle, and again, we're going to give it sort of specifications, the X values, the Y values, and the radius as well. Enter is sort of a specific thing to D3. I kind of think about this in terms of a play or something like that, where actors and actresses will enter into the stage when data is being introduced. You might update the information, so the actors and actresses might move on the scene itself, so they might move from one place on the stage to another, and they might exit, so they leave the stage at that given point. And you can do all three of those stages throughout. And so we're entering, so we're going to have our actors and actresses sort of enter the scene for our circles. And so we need to have them enter, and then we append their actual objects at that point. So we're going to append circles. So for the most part, we have those three lines that are going to take care of this, where they are in space, so the X, the Y, and then the radius as well. Because we're using the data to sort of inform this, we actually have to specify a function. And I think I kept this from yesterday specifically when I was going through this talk, but for the most part, we'll have something called function, and then we'll give it the D variable, basically meaning whatever the value is. So this can be anything. So if I name it Apple, the variable, and so basically when it goes through, it's going to have each of those data points. So when it runs, it's going to have 2. So it knows to put the position at the 2 position, Y position at the 2 position, and then the radius is going to be 2. And then 3, and so on and so on and so forth. So again, if I change this to 305, it's going to move it all the way to the 305 position for both the X and the Y, and change the radius to be 305. All right. So that's how we get started with D3. And again, I understand that this is Very simple array, very sort of minimal idea in terms of this, but at least kind of get us moving in terms of creating and sort of putting these objects together. From there, we can obviously see that we have sort of to be perfectly blunt with you, a very ugly sort of image. It's not really sort of intuitive. It doesn't really tell us in terms of, they're all kind of scrunched together. And so all I'm doing in here in the next step, same exact idea from before, but I'm just going to multiply all those values. So just kind of keep copying this along. That's here. There you go. So it's going to take the value 2 multiplied by 5. So it's going to be at position 10, then 15, 30. I won't do the math from here on out, but you know what I'm talking about here. So if I want to, I can say I want the radiuses to be 5 times as big as well. Kind of too overboard at that point, so maybe we just need it twice as big, or maybe, hey, let's make it half as big. So it's actually using the values from our array to sort of dictate, this case, the radius, or we can do it by position as well. And that's where a lot of the power comes into play in terms of D3, is you're letting the data sort of dictate the positioning, the size, the color, the things of that nature as well. If by chance you've wondered at this point why, even though I'm talking about an XY coordinate plot, one of the things that people sort of ask me at this point is, why is the XY coordinate plot starting up here in the top left-hand corner? Typically, we'd sort of assume that it would be kind of moving from bottom left to top right. We're increasing it's a linear function, if you will, because we're basically using, completely correlated types of information. So it would make sense that it would kind of go from the bottom left to top right. For some reason, the XY coordinate plot actually starts in the top left-hand corner of the screen. And so this next line of code is basically our way of sort of making sure that we actually, we use the bottom left-hand corner to sort of start our conversation at. So only thing we're adding to this line here is basically adding a scale. And these scales are going to be more important specifically when we want to add some axes to this plot as well. So when it comes to this, and this is where I'll use my MS Paint skills here, what we want to do is think about 2 different things. We want to think about sort of the range. So the range is basically, if we're making, if this was our div or the screen that we want to talk about, we need to know, let's say from the x-axis, we want to think about the range. So the range would basically be from one side of the screen to the other. And so we're going to be kind of considering that to be sort of the width of the screen. So I'll just say width. And so that's going to be the range that we're going to be talking about. We're going to have a range that goes from 0, because the left side is 0, and then the far right-hand side is going to be the width of the screen or of our plot or whatever we want to sort of call it. So it's going to go from 0 to the width, or 400 in this case. Same for height. So if we want to do the y-axis, and again, sort of the y range, the only thing that's a little bit different is the fact that instead of 0 being sort of at the bottom of the page, it's actually 0 is at the top. So 0 would be up here, and then we'd actually want to use height, to be down here. So that's going to again sort of dictate sort of where the y sort of axis is going to be, or where our range is going to be for the y-axis. And so that takes care of our range. I do change this a little bit just because I want to make sure that we kind of fit everything in within our screen. If I change this to 0, it kind of disappears a little bit. So I want to make sure we can see everything. So I had to make it sort of squeeze it in a little bit. So our width is going to be 400. And so we're saying from 0 to 350, if you will. And then from 400 to 50, again, let's sort of make sure we kind of get everybody on the screen here. If I make this 0, again, starts picking up at the top here. The next thing we need to know is the domain. So this is basically, we want to take each of these values, and basically we want to be able to plug it in specifically for the range and the range for both the x-axis and the y-axis. And what we need to basically know from here is the lowest value and the highest value. That's sort of a good idea in terms of, we want the left-hand side to be the lowest value, and obviously the right-hand side to be the highest value. So that's sort of what we're dictating here. We're trying to find the lowest, highest value. In case, in our situation, let's say I'm going to change our, I'm going to bring data down here as well. In this case, I'm going to change this up a little bit and say 45. So it's not in order anymore. So we want to sort of figure out a way to do this dynamically, or a little, a shortcut sort of way to handle this, where we want to have the JavaScript tell us, just give us the highest and lowest value. And so if I change this, I'm going to go here, 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 and change this. Again, I'm just renaming it so it doesn't use data that we talked about before. We can use a function called D3.extent. D3.extent basically is a function that finds the lowest and highest value. That's all it does. And so it's going to return to us, we're not going to visually see this, but it's going to return to the program the lowest and highest number. And even though it's out of order, it's just going to find the lowest and highest one for it. So if we run this, we should have 7 points now. So we have a little one here, 2, 3, 4, 5, 6, 7. And that's going to be our 45 here, that larger circle at this point. Even though it's at the beginning of the position, it's smart enough to just say it's our largest value. So that defines our XY coordinate plot. And the nice thing is as well, is if we add more data to this, and we start to kind of get off the screen at this point, make it a little bit smaller. We can keep adding more and more points to this, and it's going to just keep adding it for us and redistributing this for us automatically. So I don't have to go through and recreate all this and say, I want to move that circle here relative to this one. It's taking care of this for us automatically. So that's going to be basically this, and the only thing that changes here is that when we read values in, we're going to read it directly into those particular functions. So that X is basically a function that says we're going to have a linear sort of relationship between the range and the domain. And same for Y as well. So that's all we're doing. That's changes here. Next thing we're going to do is add some color. Basically, we've talked about sort of separating values at this point based on one of the things you want to do is encode information. So we can do it spatially. So obviously we can take positions that are larger. We're going to stick them out farther away from values that are smaller. We can use things like size. So that's what the radius value is. Another way we can do this is use color. So in this case, we're just going to use a color scheme through D3. I'm not going to go into a tremendous amount of detail when it comes to color. I have a link available here. You can kind of look at the various ones that are available for D3. But you can, if you just copy and paste this, this will basically take care of coloring for you throughout the rest of this process. It uses something called an ordinal plot. So no matter what you feed into it, it'll automatically sort of generate another color for you. And schema category 10 basically means it has 10 colors available. So if we had, our array was 11 characters or 11 numbers long, eventually it would start repeating. There's ones that you can do for 20 as well, but for the most part, we're just going to use 10 for this, basically this conversation, for the rest of these examples, if you will. But I recommend checking out the link just to kind of see other color schemas that are available. This is a style, so we're going to be changing the fill of the actual object. And this allows us to introduce one of our second little things that we can add to these functions. So for the most part, this D basically represents the data itself. So the 2, the 3, the 6, 19, 23, and 35. If we add one more variable to this, this will give us the index. And so basically this is index down here, that smaller little one here is going to be 0, 1, 2, 3, 4, 5. It starts at 0 because it's computer talk. And so it goes, for the data itself, it's basically 0, 1, 2, 3, 4, 5. So even though there's 6 here, it's 5 because, again, it starts at 0. And that lets us just basically use, if we want to use indexes as our way to put new coloring or new variation. So let's say we wanted to choose index for this and then multiply it by 5. I would have to add that as well. It'll actually use the index instead of the actual values itself. I don't want to do that right now. I'm just going to use the data itself. There we go. Yeah, so that's sort of two ways you can actually input new variables into, or excuse me, two different variables for our functions. And these are the only two that are available. So again, you can use the data, which is actually representing the data within our array, or index, which basically means its position within that array. Our next example goes into actually adding some axes to this particular plot. And so far, if you kind of understand what's going on in terms of these X and Y, and I actually added one as well for our radius, just to kind of change things up a little bit. Not only can you do scale linear, you can do scale power, so you can have exponents. I don't want to go into too much detail in terms of sort of those variations, but you know, you can have exponential in terms of how color is being added, or radius, or something to that effect. And I just wanted to have a sort of a line to have that sort of in play as well. But you can kind of look into that, so we can talk later about that. And the exponent basically means we're going to bias values to one side of the spectrum or another. One thing that looks a little bit different is the fact that if I would just use the extent, what would happen is basically it wouldn't be 0, 0 here. It would be 2, 2, and it would be off a little bit. So what I'm specifically doing is saying, instead of it being the extent of lowest and highest value, I'm going to use 0, because I want a 0 position here on my x-axis, and I want to have the max value. So all this function is doing is another D3 function that says, just give me the max value out of my array here. And that, again, sort of would be, let me read this along with me, would be 35. So let me add this again. Manually doing this real quick. Hopefully everything works properly. Yep. So let's say we added one more for 45. It automatically says, okay, the max value is 45. Let's just change the X and Y axis to sort of meet that. So again, this is just declaring where the X and Y sort of the scaling that we're using. And to add X axis, all we have to do is add these two lines. We're going to be adding basically a placeholder. So that's what this G stands for. The G basically means a subset. It's not an actual object. It's not a circle. It's not a line specifically or anything like that. It's just basically we need to put the axis here. And this is automatically done. If you put this particular line in for here and say axis bottom, it's basically going to take the x-axis that we sort of declared up here and place it at the bottom of the screen. And we can do that again for x-axis left, which is basically, again, it's going to add an axis for the y value on the left-hand side of the screen. I believe if I do axis right, axis right basically moves it from the text being on the left-hand side to moving the text on the right-hand side. Sorry, I just wanted to try that out real quick. I haven't done that before. So axis left basically has it on the left-hand side and vice versa on the right-hand side. If we actually want to move where it's located at, we basically have to transform or translate it or move it to that position. That's what this part here is doing. It's taking the x-axis down here and moving it to the bottom of the page. So if I actually remove this and say 0, it'll be up here, but we want it at the bottom of the page. So we use the height basically because, again, 0 is up here and height is at the bottom. That actually moves it to the bottom of the page at that point. Straightforward for the rest of it. This will plot it out for us in terms of, again, as data is coming in, so it's at 50, it's going to automatically sort of have the axis sort of change specifically to that point as well. If we wanted to, we can say 2 and 2, run this again, and we won't see the 0 position. And that's exactly why I wanted to make sure we had a 0, 0 there. It's now starting at 2, 2, basically, and we don't necessarily, not the best in terms of what we're typically used to seeing. So we want to see 0, 0. And it also moves that blue dot a little bit away from the X and Y axis. In terms of this, there's a couple, I'm going to actually skip a couple of these things, but I'm going to talk about specifically something called transitions. If you go into our presentation, I talk about this idea of change blindness. There's a couple slides in terms of some examples of why we should utilize something to sort of address something called change blindness. But basically, we're sort of tied to when something changes, or even something as simple as blinking. If we don't sort of concentrate on objects, we actually sort of lose their sort of relationship between what they saw before and what happened afterwards. Typically, people talk about this, well, you know, why you shouldn't look at a cell phone or a smartphone while you're driving, because you kind of miss the differences between what you saw before and saw afterwards. So change blindness is sort of the reasoning why transitions are sort of kind of a cool thing to have, specifically to help make sure people understand that data is moving and it just doesn't change from one state to another state. You can actually see the change, if you will. So here's an example of that. If I run this, I don't have any points, and all of a sudden they just all magically show up. What's going on here is that we're going to be adding that transition. So the transitions are basically change. It's going to have one state, it's going to go to that final state, and it's going to do it smoothly through that process. So the one thing you might notice here is the fact that my radius for this is going to be 0 for first declaring this. We can then select all of our circles again. We can add a transition. Duration basically means how long it will actually take. So, and this is a millisecond. So if I wanted to, I can have it happen really fast, or I can go very, 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 very slow. It'll take a little bit of time for it to actually show up. So 10,000 basically means 10 seconds. So that's, again, it's milliseconds for that. And all we're doing is saying, okay, well, our original value was 0, and we just want to have the actual radius. So let's say we want to make all these 10. It'll transition from 0 to 10 positions, and it'll automatically do this for us in a smooth way. Again, this is meant to be sort of to help people see, to sort of recognize that there's a change going on. We can also add things like delay. Delay basically says, at that point, everything is happening at once. We want to delay this. So basically, we want to have delay it so the last value up here would go last, or vice versa. So let's say I want, as you can kind of see this transition. This transition specifically is saying we're going to move, basically, we're going to start everyone at the bottom left-hand corner and then move them to their actual location. We're going to delay this so that the first blue dot goes first. The next one happens 500 milliseconds later, 500 milliseconds later, 500 milliseconds later. So if I run that again, you'll see the first one's moving first, and then the last one's moving last. What I have here basically sort of reverses that logic. So if I run this, the last one should move first, and then the rest will move from there. Pretty straightforward. And that's what you kind of see in terms of the visualization that I showed at the beginning of this conversation. That's what's being done, basically. Another thing we might also want to do is change the way it progresses from one state to the next. So if I rerun this, it has something called, it has sort of an elastic sort of look to it. Kind of just more for flair, if you will. There's different types of eases, if you will, and I have a sort of a link for that. I'm not going to spend too much time on it, but you can just basically change the way, instead of it moving smoothly from one state to another, it has sort of elasticness to it, if you will. And there's a number of different ways you can actually do that. Some other things that we might want to include as well are things called affordances. And I actually will bring up my presentation for that. Affordances are basically when things are designed and put together, if they're created intuitively, we should know that there's some sort of interaction that's supposed to take place. To sort of demo this, I usually will use images or pictures of poor affordances, if you will, so bad sort of representations of affordances. If you've ever gone to a movie theater and ever saw these wonderful sort of both sides sort of door openers, so you push on it so it opens the door. I'm not sure if you've ever had this situation occur to you, but basically I've walked into those doors because I was pushing on the wrong side. These are basically poor affordances. It tells you there's something supposed to happen, but doesn't give you sort of an idea of maybe a direction or how to actually interact with it. Some other ones that I've seen, students, I've taught classes like this before, so students have sent me pictures. This would be sort of another example of a poor affordance. You can't really tell which one's the men's room, which one's the women's room, or something like Target. These are still seen today where it says enter only, do not enter. These are bad examples of affordances. And so affordances is basically tied to making sure we know that something is supposed to happen. It's sort of built into the visualization directly. So for this, we're going to add something called mouse events. D3 supports basically a wide range of mouse events. Basically, the mouse events are things like clicking, double clicking, mouse over, mouse out, basically moving the mouse over it, moving the mouse out. And all we're doing is changing the stroke width. So when I mouse over, you see that it changes the width of the actual, not the width of the circle, but the width of the actual stroke. So that's why we see a darker line here. So if I go through here, it should automatically do that. So it sort of gives some sort of an intuitive sort of notion that something is supposed to happen here. In this case, I added a title, so now when I mouse over these, it's going to tell me the data value is 35, and that's this line here. And that, again, maybe you have a specific action. Maybe you have it. You can click on it and you drag it to a new position. Maybe you'll click on it, it'll take you to another web page. But it just gives somebody the intuitive notion that something's supposed to occur here. And again, this is just sort of small things that you're going to do for visualization, specifically dynamic ones, if you will. In terms of the mouse events, like I said, there's mouse over, mouse out, a number of different ones that sort of allow you to interact with this. They're tied directly to the objects themselves, so it makes it a little bit very easy to actually add these mouse events. There's also ones for touch events, so things like clicking on your smartphone or an iPad or something like that. Those are touch events, and so you can add those as well. Again, I won't spend too much time on that, but you can kind of look into that if you're interested in adding some of those features. The last thing I'll be talking about specifically with this is updating or adding new information. So at this point, we've just kind of seen when we have a data set, no problem. Here's this data set again. So we'll go here, and I'm going to call this data sets. So our boring data set that we've been using up to this point. Sure, this still runs properly. All right, there we go. There, much better. So what I'm in this actual visualization, the thing that's changing is basically every time I click on this particular graph, it's just going to push or add another value automatically. And this value is going to be from, this is just a JavaScript sort of bit of code that basically says, give me a random value from 1 to 1,000. That's all that's going on here. And this is basically, instead of me going through and adding it manually, so I'm in 45, I read it from the code, there's the extra point. It's going to automatically just keep adding new numbers as I click on the actual graph here. And again, this is just to showcase how to add more information to it. The only thing we need to do to sort of update our X and Y axis is we change the domain. So again, sort of if we go back to our image here, it used to be 2 and 35. We add a couple new, we're adding more numbers, we're adding new numbers. We just need to find the lowest, or in this case, the highest value because we have a 0 position. So find the max value, redefine our X-axis, redefine our Y-axis, and then we're going to have a transition. So it's going to sort of smoothly transition this X-axis to this Y-axis. In this case, we're also going to append any new data that needs to be added. And we're also going to update the positions of the other ones. Because if we add, let's say, a new data point that is at 1,000, obviously all these other points need to be kind of pushed down to the bottom left-hand corner. So I'm just going to click on this, and you're going to see basically what I'm talking about. This X-axis, excuse me, the Y-axis and the X-axis are automatically changing for me. The other positions are sort of figuring out where they need to be relative to one another. And we can kind of just keep clicking and so on and so forth. And for the most part, this is, this just a simple example of how this interaction can occur. So just to kind of outline this, that was sort of the main sort of outline in terms of the tutorial. Again, we've covered things like, starting a D3 project, running it in a Jupyter environment, being able to kind of refresh these cells so we can add new information in. We changed our array a little bit. We also went through things like transitions. We went through adding new information. We added things like colors and affordances, so also over events as well. That kind of covers the spectrum in terms of a lot of the things you can work with D3. There's a lot more to it, obviously. So what I have here sort of to kind of end the conversation for today is sort of a complete project, if you will. A lot of this is going to be Jupyter is specifically made for something called Python. Python is just another programming language. So this is meant for Python code, and that's what's going on here. I'm not going to go into the nitty-gritty, sort of the details here, specifically just because of the fact that, again, this is sort of a advanced form of this conversation. This is kind of going through, this would probably take me an hour to kind of walk through for somebody who's new to this. So, but I just wanted to sort of showcase what's going on. An actual complete project. So here we're reading in a CSV file. We're going to split that particular file. I'm not necessarily caring about what the headers are for this. All I'm looking for is data. And it just so happens, if I preview this data, I see a couple rows of information. And this data is actually the same data that we saw before with the visualization where we were moving from the antibody counts down to specific infection dates. So this is where the actual data is coming from. So we're trying something new with it. And the actual data that I'm caring about is that first column here for the actual antibody count. So I'm just going to kind of make a histogram, if you will. So that's what's kind of going on throughout the rest of this. A couple things going on. You're going to have some data. We're going to read it in. And so in Python, you append to our array instead of push, as you would do in JavaScript. We can say in JavaScript, or excuse me, into Python, I want to showcase the first 10 positions, or 11 if you will, because you're counting 0. So that's what's going on here. It'll tell me what types they are as well. So these are all strings. And so this line here is basically saying, I would like to make these into integers, so actual numbers, and we're going to round them to the 100th position. So that's all that's going on here. So our original number was 1810. We're going to change it from a string to a integer of 1800. And then so 10 becomes 0, 10 becomes 0, 10 becomes 0, 39 becomes 0, and so on and so forth. And so basically I'm just rounding to the 100th position. We read our data in, and at this point we're going to create the same scaling as before. So we're creating a bunch of circles. And so if we think about this, this is 0 over here, and 1800 over here. And that's very pretty at this point. As we move on, we're going to be able to add some more coloring. So this, because it's outside of our 10 sort of coloring, I'm using specifically some interpolations of color. Again, follow the link if you're interested in further learning how to do that as well. But it's a little bit more fancier, so it actually has sort of a high value or a low value for, in this case, purple, all the way to a yellow color. So that's why you have sort of unique colors throughout the spectrum, if you will. And we're adding the axis as well. So again, we have 0, 100, 200, 300, 400, 500, so on and so forth. The last thing we have is actually, at this point, we have all these values. We have a bunch of ones for 0. We have a bunch of ones for 100, or for 200, and so on. It'd be really cool if this visualization would actually figure out where it needs to go. Basically, what we want to do is we're going to add, this is a little bit of a teaser, if you will, for next conversation. We're going to be using a force-directed graph algorithm, or the force simulation, to create something called a swarm plot, a B-swarm plot. And so if I run this, it takes all the positioning and for the zeros and basically says we're going to have some specific separation between all of these. And so it sort of actually does this dynamically for you. And again, this is sort of just a bit of a teaser for next time. Not a lot of code that it's actually added. We just have to say, we use that X to sort of dictate that we want to have sort of a cluster here for all the 0 positions, all the 100s, for all the 200s, and so on and so forth. And so we got this cool little kind of moving sort of plot, if you will, that's sort of moving the positions of all these points to where they actually need to be relative to one another. That's all I kind of want to talk about for today in terms of this general conversation. I have a survey. So in case you're interested, you can add add some comments. Just to kind of give you some feedback in terms of specifically what's going on. Again, it just helps out in terms of the conversation. So let me see if there's any kind of questions. And if not, I will end our conversation for today. Again, if there's any questions, please let me know, or feel free to email me. I'll be happy to respond to that as well. Again, if there's no questions, I'll probably just end our conversation for today. But feel free to email me, pmd19@psu.edu. I'd be happy to talk about any of these projects I'm doing or anything like that because of the visual stuff. But for the most part, it's more or less, hopefully this will continue on for the next conversations. But if there's no other follow-up questions, I'll be ending the meeting at this point. If there's any questions, please again feel free to email me. And I look forward to our conversations moving forward as well. So thank you very much, everybody.